Okay, students, this is the second time I'm making this video, an introduction to 10.2. We're talking about graphs. Now, in honor of the World Cup, not that I'm the greatest soccer fan, but I used to coach soccer, we have the orange visual curve is representing the path of a soccer ball. And we realize that this is time right here, time in seconds, and then we're going to do height in feet. So my question is what is F or H, the height? What is H of 0? Well, it's the height of the ball when the time was 0. So there you go, you got 2. Here's 1 second, 2 second, 3 second. Looks like it hit maximum height there. 4, 5, 6, 7. Okay, at 7 seconds, what was the height of the ball? 0. It was on the ground. So H of 0 is 2, but the 0 of the function where H of x is 0 is 7. So keep that distinguishment in mind. The 0 of a function is where the value of the y is 0. It's only 0 here. Another thing we can notice about this visual aid is the domain. The domain is limited here from time equals 0 to time equals 7 seconds. We don't know what happened after 7 seconds. Someone could have kicked the ball. The game could have been over. We don't know. And also we know something about the range of a function. The range of a function would be the values of the y, or the height. What's the lowest it got? What's the highest the ball was measured in? Well, here the height was 0. It was on the ground. And here it was, well, what is that, 2, 4, 6, 8. Who do appreciate USA in soccer? I don't know. Okay, so here you go. So the height right here, the highest it got is like 8. So what is the range? The range is from 0 to 8. I hope that makes sense. Now, the ball did reach a maximum height here, and we can understand that the ball was increasing from here to here. It was increasing all the way up here. It reached a maximum, and then it decreased from here to here. So whenever the value of the function or the curve is going upward as we travel from left to right, it is increasing. What if I kicked the ball and it got stuck on a building? Then it would be a constant height, right? Okay, so we keep that thought in mind as well. Now sometimes a curve will go up, down, and up again. This would be called a relative maximum. And I could say that point right there is 3, 8. So the relative max was 8 at the domain value of 3. All right. Now let's look at another type of function here, something we can all relate to. Let's just say you're starting a business and you're coming up with a new cell phone. By the way, in biology class, we know about the communication between cells. And by the way, how does the animal cell communicate with the plant cell? Cell phone. That's a joke. Okay, I tried to plant that one on you there. All right, anyway, so now I have a business. I'm making a cell phone. And let's just say that the orange curve is representing how much money I'm bringing in. Obviously, we sell nothing, we make nothing. And so we're selling the phone for a certain amount each. And let's just say the purple represents the cost of the phone. It cost me $1,000 to set up my equipment. Now, in the real world, it would be more than that, right? But let's just say that $1,000 represents my initial cost, and then it costs to make each one. Obviously, we want to sell them for a higher price than it's costing us to make them, okay? People normally are in business to make a profit. Now, so if we take a look at this graph, we understand there's a special point where both graphs touch. This is known as the break-even point. It's not a maximum, it's not a minimum, it's where two graphs cross. And so the value would be 300 and I don't know, what would that be, like 1400? So that's the break-even point. I would need to try to make more than 300 units and sell them, okay, to break even for my business. I definitely want to stay in this range. Maybe we should go on the Shark Tank for that. I don't know. But I hope that illustration makes sense. I'm sorry, that's a money joke. I tried to sell you on it. No, I'm sorry. All right, now, the next thing I need to talk to you about is this notion of even or odd functions. This tends to get people, and it doesn't have to. It's not that bad. Let me move this out of the way so you can see it better. Okay, now you can see everything. There are a lot of functions that people study in life, business, science, and so forth. It helps us to be able to distinguish between an even function and an odd function. An even function is where f of negative x equals f of x. Or you have the same y value for opposite x values. Notice in this case the y-axis is serving as a line of symmetry, a lot like your body has a line of symmetry. Hope that makes sense. Now, what is an odd function? An odd function is where f of negative x is equal to negative f of x. Now, if you understand that completely, fine. If not, you may think I'm talking some ancient Egyptian hieroglyphics, okay? But really, you can understand this. So let's break it down. Here I have a graph. F of x is equal to x squared. So square 0, I get 0. Square 1, I get 1. Square 2, I get 4. Now here's my table of values right here. Now my question is, what is f of 1? F of 1 is 1. What is f of negative 1? F of negative 1 is 1. Don't they have the same y value? Yes, they do. So for a different value on the domain and the range, they have the same y value. That is the idea of an even function. Notice f of negative 2 is 4 and f of 2 is 4. They're both the same. That is it. Now, how can you tell if a function is an even function just by looking at the algebra? Well, whenever the power is even, the function is an even function. Now, here's an example. G of x is x to the 4th plus x squared plus 2. Is that an even function? Well, if I moved that function up 2, it still has the y-axis splitting it down the middle, so yes, it is an even function. Can we reword that as a rule to help me in my work? Yes, we can. To see if a function is an even function, look at the powers. If all of the powers are even, it's an even function. If you have a constant, that's okay. You can have a constant in an even function. All right, so we're through with the even function. Now let's look at an odd function. Not that there's something strange or wacky about it, but the notion or the concept of an odd function. Here we would have f of negative x is equal to negative f of x. All right, what does that mean? Well, what that means is f of 1 is 1 and f of negative 1 is negative 1. Let's try that again. F of 2 is what? 8. So f of 2 is 8. So what's f of negative 2? It's negative f of 2. Or if you don't like that, if the opposite domain values are located, then the y values would be opposite. Notice how the curve looks. Kind of looks like a propeller, part of a propeller, okay? That is the notion of an odd function. Now, is there some symmetry with an odd function? Yes, there is. There is what's called point symmetry. Point symmetry with that particular point right there, which is the origin. So remember that when we're talking about an odd function. All right, so how can you tell if a function is an odd function or not? Well, look at all the algebra in the expression of the function. That's odd power, and x by itself is 1, so that's an odd power. That is an odd function. You could actually put that on your graphing calculator and see. Now how about this function right here? F of x is equal to x plus 3. Well, that's a good question. So what would f of x equal x look like? That would just be a line going like that. What if it's plus 3? That means that I moved that line up 3. Now my question to you is, look at that line. Is that line symmetric with the origin? Does it have point symmetry with the origin? And the answer is no, it does not. So when we're talking about an odd function, if all of the powers are odd, it's an odd function. What if there's a constant? It's a no-go, okay? You cannot have a constant in an odd function, so keep that in mind. And one last thing about this, if you have a mixture of even or odd powers, it's neither. It's neither odd nor is it even. So I hope that makes sense, because you're going to see that from time to time as you study more about functions. Well, I think that's all I had to say about this unit. I hope that you do well, and look for other videos in this lesson discussion that may help you. Thank you.